Okay, example 4, use your graphing calculator to help graph f of x equals 3 to the x plus 3 to the negative x over 2. If the function has a horizontal asymptote, state the equation of the horizontal asymptote. This is what I would call a not basic exponential function. It's very non-basic. You can see here I've just got a chart with a bunch of space in there, so I'm assuming I'm going to get a lot of points. There's no real rhyme or reason to how to pick. Here's what makes my decision for me. I have an x power and a negative x power, which means whatever I pick positive, the negative version is going to give me the same answer. Because if I put 2 here, I get negative 2 there. If I pick negative 2 there, I get positive 2 there. So the negative and positive answers are getting the same thing. So I'm thinking it's going to be centered around 0 and going in both directions. So I'm going to pick numbers near 0 going out in both directions. And expecting just whatever points I get, 0 is going to be whatever it is. Then it's going to kind of, wherever it goes, up or down or whatever, it's going to be the same on both directions. If I go to my calculator to type this in correctly, again, typing in correctly is key because your calculator is going to be doing the evaluating for you. All right, I've got 3 to the x plus 3 to the negative x on top as a binomial expression, so I need to put parentheses first, 3 caret x, and again, if you got the classic notation, caret x, it's done. As soon as I hit plus, now I'm out of the power. If you got the math print notation, you're going to have to push to the right to get back down to the right level. I'm going to do 3 caret negative x, and negative isn't an x, so it's expecting a number or a letter there. So once it gets the letter, the negative sign is included there, in parentheses, all divided by 2. As far as numbers I'm picking, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. I've got 15 spaces. I'm just going to pick a big number. I'm going to pick 5 just to see what happens. 5 is ridiculous. I don't want to pick 5. So let's go to like a 0.5 scale here. So 0.51, 0.52, 0.53. So I need to go positive, negative 3 from 0. So 0, 0.5, negative 0.5. 1, negative 1. 1.5, negative 1.5. 2, negative 2. 2.5, negative 2.5. 3, negative 3. And that's all I really have room for. Again, I'm going extra 0.5 scale. I don't know about the y scale yet. All right. Once we get our answers out, we'll see what we need to get to, and we'll scale that based on that. If I type in these numbers, and just if you take a look, 0 of course is 1. If we put 0.5 and negative 0.5 in, they're exactly the same thing. So you don't have to do each one, just do 1 and then just know they're the same. So this is 1. This is 1.15, so is this. And if I put in 1, I get 1.67, so they're both 1.67. Next number is 1.5. We get 2.69, 2.69. Two, 4.56, 4.56. 2.5 is next. 7.83. Oops, picked up the wrong color. Doesn't matter. And then we got 3, and negative 3 gets me 13.52. So we get a bunch of points. 1, 2, 3, 4, 5, 6, 7. So we'll go to 2 scale. I can put them all on there. And again, 2 scale just means each dash represents 2 spaces. 0.5, each dash represents 0.5 spaces. So 0, 1 would be right here.
Well, the scale on our paper was 5.
Oh, was it 5?
Yeah,
The y is 5.
How far did I go on X?
It didn't go
5 spaces.
5 spaces. Maybe I was expecting 5. I don't know. Well, just make the 5 a 2, and then we'll go with that. So 0, 1's there. 0.5, 1.15 would be just a little bit higher, so just a little bit above halfway. And then we get 1.67, which is getting closer to 2, but not quite there yet. 2.69, we surpassed 2, and we go, there's 3, so 2.69 would be a little bit below half. 4.56, 2, 4, 5 would be here, 0.56 would be about here. Same on this side. 7.83, got 2, 4, 6, 7.83, almost 8, so about there. And I've run out of room on them. Well, I can maybe fit one more. 13.56, so 2, 4, 6, 8, 10, 12, 13 and a half, so about there. All right, and there's what our graph looks like. And again, it's symmetrical. I mean, we can see that whatever numbers we got, I put 1, -1, got me the same answer. So I just know it's going to make the same shape going both directions. Kind of makes a weird parabola shape, but not quite a parabola. I need to line my board again because I don't feel like I'm having very much success being online. As always, good graphing policy, put arrows on the ends of your graph. As far as horizontal asymptotes are concerned, it needs to be approaching some number, leveling off. This seems to be going up to infinity, so it doesn't have one. Sometimes they do, sometimes they don't. Okay? When it's number raised to a power, it always does. When it's something like this, sometimes it does, sometimes it doesn't. So it really depends on your graph. So if you see a leveling out happening, you know there's a horizontal asymptote, pick some big number. In this case, my big number 500 resulted in an error because it got too big for the calculator to be able to calculate it anymore. 3 to the 500th power is just massive. It's too big for the calculator to even know what it is. 3 to the negative 500th power is almost 0. So that's irrelevant, but 3 to the 500 is so big, then divide that by 2, all of a sudden you're going to have something that the calculator can't handle. It's too big of a number. So again, the horizontal asymptote stuff. This last one actually, if you wanted to say it has a horizontal asymptote at 0. Okay, so if you really wanted to get technical about it, as you go to infinity, the graph's leveling off at 0. All right, this one doesn't have one. So if it does, state it. If it doesn't, just you can ignore that part because it doesn't have one.